Hi, welcome to part 2 of the Lesson 5.2 tutorial video on common factors. In this video, we are going to look at how to write polynomials in factored form, and finish all of the examples from the Lesson 5.2 notes. Let's quickly review what factoring means. You looked at this in part 1 of the Lesson 5.2 video. Factoring is the reverse operation of multiplying. When you are factoring any number or polynomial, you are going from the expanded version back into a version that has its factors. In other words, you're looking at what the original expression is all divisible by. So let's go and do some examples of factoring. In example 2, we have an expression 2x plus 4 that we want to write in factored form. The first thing you need to do is identify all the factors of all of the terms in the expression. So the first term, 2x, has two factors, 2 and x. Factors of the number 2 are just 1 and 2, and factors of x to the power of 1 is just x. The second term, 4, has factors of 1, 2, and 4. Remember, you're thinking about what are these expressions divisible by. The largest factor that they share in common is 2. So, the greatest common factors of the terms is 2. Only the first term has an x, so x is not part of the greatest common factor. The next step is to divide every term by the greatest common factor. So if we rewrite our expression, 2x plus 4, we want to divide each term by the greatest common factor we identified in step 1, which is 2. When you get that, the factored form is the greatest common factor written out front, that's one of your factors, and then in brackets you write everything that's left after the division. Well, 2 divided by 2 just equals 1. So we have, and x is left in the first term, or 1x. Next, we look at the second term, which was 4 divided by 2, which equals positive 2. So we write plus 2 in the second term in the brackets. We can always check our answer, this would be the factored form right here. We can always check our answer by multiplying or doing the reverse of factoring. When you're multiplying, you multiply using the distributive property, so everything outside the brackets gets multiplied by everything inside the brackets. 2 times x is just 2x, and 2 times 2 is 4, so plus 4, which is the same expression that we started with, so we know our factored form must be correct. Alright, let's look at part B of example 2, where again we have a binomial to factor. The first step is to identify the greatest common factor. There's a little bit of an easier way to do this than listing out all of the factors of every term, and that is to look for what is the most that both terms can be divided by, and that will make up the greatest common factor. So the first thing you look at is the numbers. If we look at the two coefficients, we have 15 and 10. What number is the most that those two numbers can be divisible by, or divided by? And that answer is 5. Both 15 and 10 can be divided by 5, but nothing bigger than that at the same time. Now we look at our variables. The first term has x squared, which means x times x. The second term has just x to the power of 1, which just means x. So the most x's that they share in common is 1x, so we add that to our greatest common factor as a factor. So 5x is our greatest common factor. So we're going to divide every term by 5x, like this. So if we have our original expression, 15x squared plus 10x, we divide every term by the most that it can all be divided by, so 5x, and we write our greatest common factor out front as one of our factors, and our second factor is everything left over after we divide. Well, 15 divided by 5 is equal to 3. So we write 3, and x squared divided by x just equals x. Remember, you're dividing two powers with the same base, so you need to subtract the exponents. 10 divided by 5 is 2, and x divided by x is just 1, so we just leave our 2 in the second term. And this is our factored form. So again, you can always check your answer after factoring by multiplying out your answer. So 5x times 3x and 5x times 2 is your distributive property. 5x times 3x is 15x squared, and 5x times 2 is plus 10x, which is the same as the polynomial that you started with, so that is the correct factored form. Alright, let's look at part C now, where we have a trinomial that we need to factor. Similar to what we did in part B, we need to identify the most that all of the terms are divisible by. So first looking at the numbers or coefficients in the front of the terms, 7, -28, and 14. All of these numbers are divisible by 7, and so that's the biggest number they're all divisible by, so that's part of our greatest common factor. Then we look at each variable separately. So we have an a squared, an a, and an a. The most a's that they all share in common is 1a, so we put that onto our greatest common factor. Next we look at the b's. We have a b, and a b squared. So again, the most that they share in common is 1b, so we just put a b on our greatest common factor. So our GCF is 7ab. That's what we're going to divide every term in our trinomial by. So I've rewritten my trinomial, and I'm going to divide every term by the greatest common factor of 7ab. So I want to write that out under every factor. Then I'm going to go and divide each factor by 7ab. So 7 divided by 7 just equals 1. So I'm left with, my greatest common factor gets written out front. In the brackets, in my first term in the brackets, is what's left after this division of the first term. 7 divided by 7 is just 1. A squared divided by a is a. And b divided by b is just 1. So the first term, the leftovers are a. In the second term, we have to use -28 as our coefficient, divided by 7. -28 divided by 7 gives you -4. So we're going to write -4 behind the a in our answer. Then a divided by a is 1, and b divided by b is 1. So -4 is the second term in our factored form. In the third term, we have +14 divided by 7, a divided by a, and b squared divided by b. 14 divided by 7 is +2, a divided by a is just 1, and b squared divided by b is b. B squared divided by b, remember, subtract your exponents, so you get b to the power of 1 left over. So this is our factored form, and again, check by multiplying the front term, 7ab, by each term in the brackets, and you'll find that you get back to the original polynomial that we started with. A common factor doesn't always have to be just a number or a variable. Sometimes it can be a polynomial, such as a binomial. You will see some examples like this where you find a binomial is a common factor of more than one term. So if we look at example 1 here, we have factors of the first term. Let's list them out. Well, the first term is a bracket x plus 2. The a here is being multiplied by the brackets, so a is one of your factors. Now, inside the brackets is another factor, or x plus 2 is itself a factor. The second term, the factors are -b and x plus 2. Well, the largest or most factors that they share in common is the x plus 2. They don't share any a's or b's in common, but whatever's inside the brackets is the same, so it's the same factor. X plus 2 is the greatest common factor of these two terms. So, to factor that out of the expression, we're going to rewrite the expression and divide each term by the greatest common factor, which was the binomial x plus 2. Make sure you leave it in brackets. Now, anytime you divide a number by itself, it equals 1. Well, x plus 2 is just a number, whatever it equals. We're dividing it by itself, so it's going to cancel out or equal 1. So we're left with, in our answer, the factored form. The greatest common factor is written out front, and then in brackets behind that factor we write the leftovers after dividing. So in the first term, the x plus 2's canceled out to 1, so we're left with just a. And in the second factor, again, the x plus 2's divided by x plus 2 just equals 1, so we're left with minus b in the second factor. If you wanted to check your answer, you can take your greatest common factor, x plus 2, and multiply it by each of the terms inside of the second set of brackets. X plus 2 times a can just be written as a times x plus 2. And x plus 2 times negative b can be written as minus b times x plus 2, just like our original polynomial. Okay, let's look at the second example where you have a binomial factor. In the first term here, we have 3x and x minus 4 as factors, and in the second term, we have 5 and x minus 4 as factors. The most that they share in common is the binomial. X minus 4 is your greatest common factor. So x minus 4. If we rewrite our polynomial and divide each term by the greatest common factor, x minus 4, we can see what our factored form is. So write your greatest common factor out front, and in brackets is everything left over. The x minus 4's divided by x minus 4 just equals 1, so we're left with 3x from the first term, and from the second term we're left with plus 5. So here you have your factored form. This method is very important when we look at the next examples of factoring by grouping. Please see the next short video on how to factor by grouping, which will finish off the lesson 5.2 notes and examples.